bigger, that means the number's going to get smaller. Yes, like you've answered that on a test a couple times, but I'm just going to keep bringing it back until you remember it forever. And for the last one, you actually had to do that math yesterday in your work, but to figure out that crossover temperature, you just set delta G equal to 0 in sulfur T, because 0 is not negative and 0 is not positive. So it's neither spontaneous nor non-spontaneous. When the music starts, I need you to talk about this stuff. You need to be done with chapter 19 and understand it before we move forward. Today we're going to learn a simple 13-step process to balancing equations.
13, you said?
Yeah, so we have like a huge learning day, so can you please just double check with your battle buddy that you get this stuff, and then we're going to learn, okay? Ready, go.
Which I literally have done.
This in your, okay, you're good. This is in your notes packet. Let's do it. I have some new brain eyeballs for you. Most of the stuff I need you to remember is from, I think it's chapter 5 or chapter 4 it was, when we learned oxidation numbers. That's coming back. I put it on the exam, so at least you studied it another time. But remember, oxidation numbers are like pretty much like their charges, right? The difference is oxygen is always -1, but basically it's their charges. So look up here at brain level today. Here I have zinc solid. It has an oxidation number of 0, right? Things by themselves are 0, it's neutral. This has an oxidation number of 0. Here is a zinc ion. It's zinc acetate. The acetate does not matter. It's a spectator. I know sometimes we get hung up on it. Like it doesn't matter. It's not doing anything. The point is it's over here it has an oxidation number of 0. Over here it has an oxidation number of 2+. This I can see with my real eyeballs. Like look at it. It's right here. This I cannot see. I cannot see the zinc 2+. So from our eyeballs, from here to here, it disappears. Okay, that's like a super important thing to remember. From here to here, what happened was I lost 2 electrons. I went from a 0 up to a 2+. Up means it was oxidized. Oxidized means it lost 2 electrons because electrons are negative. Okay, now look here. Here I have a 2+. I cannot see it. My eyeballs cannot see the little coppers. Here, though, it's a 0. I can see it. I can see the copper. So from here to here, I gained 2 electrons because I went from a 2+ down to a 0. Remember line thinking. 2+ down to a 0 means it was reduced. This unit is what if I took a wire, and from here to here I lost 2 electrons. And I took a wire, I'm like, come on little electrons, follow me. And I followed it over here and gave it to the copper. And the copper gained those 2 electrons. Things are going to happen to our eyeballs. If I can take a wire and I'm like, hey, come on little guys, follow me, follow me, follow me. The 2 electrons go into here. It's going to turn into copper that I can see. Okay? That's how a battery works. A battery works by this chemistry just happening. Like these 2 electrons have to go somewhere. And I connect them with cells, like that's why it's called Duracell. But that creates electricity. That's what electricity is this chemistry, spontaneous reactions. I didn't have to do anything, and these electrons are just moving. Okay? Today we're going to learn a simple 13-step process to balance these types of reactions. I'm going to use all of the colors. So get them. Like I'm getting into purple and orange based on the colors. And I don't even like purple and orange. Purple is at least better than green.
Purple's marker things that people
Yeah. Oh, yeah. I have a really good set.
Yeah,
What?
Use the art class for research.
Oh yeah, I refused to turn on my computer yesterday. Look at this. I took first for my birthday. Went to the spa.
How was that?
It was amazing. So I didn't even look at enriching students yet. What'd you say? Yeah, it's not a secret. I had to put in for personally.
Yeah, I know, I'm just saying.
It's good mental health practice to take days off.
Totally.
I work really, really hard. You can. You just have to like check your enriching students when you come back and like do extra work. That's what I have to do. Sometimes the work is worth it. All right. Electrochemistry is a redox reaction. That means that there's a reduction side. That's when it gains electrons. It's going down. That happens at something called the cathode. And today we will see how it splits into two half reactions. So the whole reaction is all of these beakers. But this is one half of it, and this is the other half of it. The loss of electrons is called oxidation. That happens at what's called the anode, and that's the other half reaction. Okay? I'm going to teach you the simple 13-step process to balancing equations by doing them. So can you page it, until you find the sample problems? Number one is just reminding ourselves what redox is. How do I know if something's oxidized? How do I know if something's reduced? So with your bad buddy, first talk about how do you know if it's oxidized, how do you know if it's reduced, and then do number one together. Ready, go. Over here, I chunked hydroxide with its charge. I was like, hydroxide's a -1, and there's two of them, so the nickel has to be +2, it has to add up to 0. So 0 up to 2 plus is being oxidized. 4 down to 2 is being reduced. Okay? As I teach you the simple 13-step process to balance redox reactions, I'm going to repeat myself over and over and over again. I'm going to use the exact same words over and over again. I mean, if you notice about me anyways, I do that anyways. But today specifically to help you remember it, I'm going to make you repeat it over and over and over again as well. So if you want to go ahead and just scooch right away, we're going to do lots of talking and repeating. But that's how you remember something. Simple 13 steps. Okay. Balance this redox reaction by the equation by the half reaction method. The half reaction method is how you do it. I don't know why it needs a name. It just needs a name. There's a different process for acidic versus basic. So it will tell you acidic or basic. I'm going to teach you acidic first, and then I'll teach you basic. The first step is to split it into its two half reactions. So if this is a whole reaction, we're going to split it into the left side, right side. How you do it is just find its partner on the other side. They're not going to match exactly, and that's okay. That's what the 13 steps do. You just got to have the same elements in there. Okay? So I'm going to say this chromium guy goes to the chromium guy, this chlorine guy goes to the chlorine guy. Okay? I'm going to start in the middle on purpose because I'm adding stuff to both sides. So I'm going to start in the middle with my first half reaction, and I'm going to copy it exactly. The charges are the most important part. We cannot forget them. They are I'm losing 2 electrons. Come on, little guys, come over here. And I'm gaining 2 electrons. It has to match, so it has to be perfect. Okay? So, step 1, split into 2 half reactions. Step 2, balance everything other than oxygen and hydrogen first. So, I have 2 chromiums on this side, 1 chromium, so I'm going to write it 2. Step 3 is to balance oxygens by adding water. So if I have 7 oxygens over here, I'm going to add 7 waters because each water has 1 oxygen to it. And then we're going to do one more step and I'll have you talk. Step 4 is to balance hydrogens by adding H pluses. So now I have 7 times 2 is 14 hydrogens, so I'm going to add 14 H pluses to this side. You are going to say those steps to your partner and they will say it back to you. So you're saying it, hearing it. Ready, set, go. This is like a super good lesson I need to record too. I can't screw up. Okay. Our next step is we are going to balance charges. We're going to balance charges by adding electrons. Electrons are negative, so it brings our number down. Brain eyeball number line. Okay, so now watch. Look up here. Look at me, because otherwise you're going to say, wait, what? I have 14 plus 1s, and I have 1, 2 minus. So 14 plus 1 times negative 2 is, this is where we're using purple, is going to be a plus 12. Do you see? 14 times 1 is 14, plus 1 times negative 2 is 12 altogether, a positive 12. Now on this side, I have 2 times 3 plus, that's plus 6, plus 7 neutrals. Doesn't matter. So over here I have a plus 6. Brain eyeballs, number line thinking. If I have a 6 over here and I have a 12 over here, I need to bring this down, not to 0, but to match. We're balancing. I'm not trying to get it to 0. I'm just trying to get it to be the same. So my electrons have to go on my left, 6 of them, so that it matches plus 6. Okay, so now I just threw 12 6s and 6s at you. Please talk with your bad buddy to see how I did that. Use words like down and brain eyeball hand signal. Okay, now I'm going to play all of those steps again with my other half reaction. So now I'm going to do back in the middle, my chlorine minus to my field. Yes, 13 steps. I like halfway, 6 steps in. I'm sorry. Step 1, balance everything other than oxygen and hydrogen first. Step 2, balance oxygens by adding waters. Step 3, balance hydrogens by adding hydrogens. I got nothing, I got nothing. The next step is to balance charges by adding electrons. I have 2 1 minuses on the left, so that's negative 2 altogether, because 2 times negative 1 is negative 2. And I have a neutral, 1 neutral on the right. Is that right? Yeah. So over here I have negative 2, over here I have 0. Electrons bring it down. So tell your bad buddy which side and how many. Ready, go. A good place to check is right here. Your electrons have to be on opposite sides. Because if this half reaction is going to lose the electrons, this half of the reaction is going to gain them. Come on, little guys, let's go over here. The thing about it, though, our next step is they have to match. These 6 electrons can't turn into 2. Like, come on, little 2 electrons doesn't turn into 6. It just happens 3 times. So our next step is to balance the electrons by multiplying the reaction. I'm going to pick orange for that. So these 6 electrons can't turn into 2. They have to match, so I'm going to multiply this whole thing by 3 so that the electrons match. Not that it's turning into it, it's just happening 3 times. So now this turns into a 6, this turns into a 3, this turns into a 6. The next step, now we're going to add them together. I don't know. That's a really pretty blue though.
I thought you said last week was the hardest. I mean,
Yeah.
it's just like a lot of.
This just feels hard because you're learning for the first time. It's really not that hard. Like adding. All right. When we add together, things are going to cancel. We've played this game lots of times. Rights and lefts cancel. When I cancel things, I do a full-on X. So that cancel's gone forever with the electrons. They have to cancel. If your electrons don't cancel, go back and redo it. You did it wrong. Okay? So now I'm looking, do my hydrogens cancel with anything? No. This isn't going to cancel. That's not going to cancel. Sometimes my waters can cancel. They're all good. So that's the only thing they cancel. So I'm going to write my final answer. I have 14 hydrogens left. I have this Cr2O7, 2 minus still, and I have 6 chlorines all on the left side of the arrow. Now I'm going to go to the right side of the arrow. I have my 2 chromium 3 pluses still. I still have 7 waters. And I still have 3 Cl2s. And everything else is gone. So now I can double check. 14 hydrogens, 14 hydrogens, 2 chromiums, 2 chromiums, 7 oxygens, 7 oxygens, 6 chlorines, 6 chlorines. A simple 13-step process to balance an equation. Okay, now you do number 3 with your battle buddy, but you have to say the steps out loud to each other. Step 1, and I should be seeing number line thinking, ups and downs. Ready, go. Okay, so let's do, oops, I did not mean to do that. Let's do number 5. And if you screwed that one up, these steps are the same thing, so maybe you'll pick it up this time. It's okay, you're fine. Okay. Step 1, split into 2 half reactions. That just means find its elements on the other side. I'm going to start with that Cn minus to the CnO minus. I write it in the middle because I'm going to write stuff on both sides. This time I'm not going to use colors. I'm just going to go ahead and do it. Step 1, balance everything other than the oxygen hydrogen first. I mean, that's step 2. Step 2, balance oxygens by adding water. So I need to put a water over here to the left. Step 3, balance hydrogens by adding hydrogens. So I'm going to do 2 hydrogens over here. My next step is to balance charges by adding electrons. So I have 1 neutral plus 1 minus. So that's a -1 altogether. Yes? Okay. On the other side, I have a -1 and a 2 plus. Number line thinking. If I have a -1 and I go up 2, that's to a +1. I need to bring it, did you go wrong? I need to bring it down, not to 0, but to match. So I have a +1 and a -1. I need to bring it down to the -1. So tell your bad buddy how many in which side. Okay. All right, let's do the other half reaction. Charges are so important. We can't lose them. That's a little -1. And then MnO2. Balance everything other than oxygen and hydrogen first. Balance oxygens by adding water. Be careful. I have 4 and I have 2. So I need 2 more oxygens over here to make it balanced. Okay? I had 4 and I have 2. Now I have 4 and 4. Balance hydrogens by adding hydrogens. So I'm going to do 4 H pluses. Balance charges by adding electrons. So I have 4 pluses and a 1 minus. So what is that all together? And over here, I have a neutral and 2 neutrals. So what is that all together? Number line thinking. I have a 3 and I have a 0. I need to bring it down to match. So tell your battle buddy which side and how many. Come on, little guys, but they have to be the same. So that means my next step is I need to multiply the whole darn thing so that my electrons don't disappear. So my next common multiple between 2 and 3 is 6. So I'm going to multiply this whole thing by 3 and this whole thing by 2. And I'm going to just update it all. So now this is 3, this is 3, this is 3, this is 6, this is 6. This is 6, this is 8, this is 2, this is 2, this is 4. I'm going to go ahead and add them together, canceling stuff that cancels, reducing stuff that reduces. When I cancel stuff forever, I do a full crisscross. Gone forever, gone forever. Because then when I rewrite, I'm like, oh yeah, that's gone forever. 3 waters and 4 waters. Gone forever. 1 left. 8 H's and 6 H's. Gone forever. 2 left. And then I'm just going to rewrite it just like I did before. I start on my top and then I go to the bottom. So I have electrons gone. I still have 2 H pluses. And I have 2 MnO4 minuses. Back up to the top, I have 3 CNO minuses. And everything else is gone forever. 2 MnO2s. And I only have 1 water. You just check in with your bad buddy, make sure they got that far. Ready to go. Are we good? Okay. Next step is in a base. If it's a base means it has hydroxides. What do hydrogens and hydroxides make? I was going to say you're really hurting my feelings. Water babies. If there's hydroxides in the bucket, which there is because it's a base, these 2 hydrogens are going to find 2 hydroxides and make 2 waters. How did I know how many? If I have 2 hydrogens, it's going to find 2 hydroxide buddies to make 2 waters. If I add 2 hydroxides to the left, just like math, I got to also add it to the right. There's nothing to cancel with it over there, but now look, I have waters to fix. I have 2 waters on this side, 1 water on this side, gone forever, 1 water. So like an extra 2.5 steps. Add hydroxides that match to both sides, update your waters, and reduce. So then my final answer is 3Cn minus. I have 1 water, 2 MnO4 minuses, 3 CNO minus, 2 MnO2, and 2 hydroxides without a hydrogen friend. What time is it? Okay. Can you just talk about that quick, and then you can start on number 6 that you have to turn the page for. And then I would really like you to practice 2 of these tonight or sometime for the day. Leave like a little time off because right now it's fresh in your mind, you'll be able to do it. But I need you to like leave an hour off. So like take it to something this afternoon and work on it, or work on it tonight. In the worksheet, there's 2 more I want you to do. But for right now, can you just talk about it and try number 6 and get rid of it? Ready to go.